Hi gang, welcome to Module 3. Let's talk about networks, computer networking, and different aspects associated with networking. All right, so in networking, our devices are networked together, meaning they are connected to other devices. And they communicate back and forth, much like a network of phones. You can connect from one phone to another. Our technology today allows us to have our computers or devices connected via a number of different ways. Now, it could be Bluetooth, could be wireless connections, could be a hardwired connection. Let's talk about some different configurations or types of networks. So we've got 5 of them here that we're going to talk about. The smallest being a personal area network. Now, a personal area network could be something as simple as you connect your smartphone via Bluetooth to a radio system or stereo system, and you can play the music off your playlist on your phone over the stereo. That's the equivalent of a PAN, personal area network. Devices that use either wireless or wired connections and different types of wireless available to us. And they're short range. You've got limitations on how far these Bluetooth connections can work. Now, from there, let's talk about a local area network or a LAN. Now, these are generally fairly small. Sometimes we'll call them a SOHO, small office or home office. Your network within your home, let's say you have a connection with your internet service provider, say Comcast or Xfinity, for example, and you get internet service from them. They are your ISP, internet service provider. They connect to a WAN, I'll talk about that in a second, and you have your own LAN in your home. So I'll dig deeper into that, but this LAN, this local area network that you have within your home, you may have a server, you may have clients, printers, multiple devices, television, displays, printers. You never know what somebody's going to have connected to their local area network. I have the lights on my 200-gallon saltwater fish tank connected to my LAN, and I can control them over the network. If I wanted to, I can turn on a camera and see what my fish are doing. Now, with that said, that's a fairly small network, localized. We've got another thing that's fairly new, and it's called a wireless mesh network. Now, a wireless mesh network, they are wireless connections. They are traditionally Wi-Fi, and they talk from one to another directly. Now, these could be an example, let's say the Ring doorbells. That's a networked security system of sorts. That is a wireless mesh network. All right. Different switches, door locks, security cameras, that's a wireless mesh network. All right. From there, we've got what's called a Metropolitan area network. The Metropolitan area network, it covers generally, so let's say an entire city or a very large university campus. We would call these a metropolitan area network. An example of which, Singapore. If you reside in Singapore, you have, by being a resident of Singapore, access to their local Wi-Fi system, wireless access points. If you're a tourist, you can pay for access over time while you're there to the city's wireless access point or their metropolitan area network. From there, their MAN connects to a WAN, the outside world, if you will. Now, you're not limited to just wireless. It can also be a wired connection. Right? Beyond that, get a little bigger, we're talking about a wide area network. Now, the wide area network is usually a geographic area. Comcast or Xfinity, for example, that they have a wide area network. Verizon, wide area network. AT&T, they have their own wide area network. Those wide area networks have a combination of hardwired fiber, wireless, Bluetooth, a variety of different methods to connect, all within the same network. Okay. And they talk to each other as well. Now, I talked about that SOHO or small office, home office network. They generally use DSL or cable connections to get a decent quality speed from our internet service providers. Now, here's a visual graphic of what I was talking about earlier. Let me make this a little bigger. That's not much bigger, so I'll go ahead and close it. In this graphic, we've got the outside world, the internet, that our ISP is connected to. So Verizon, AT&T, all the others are here. And this ISP, let's say, for instance, this is Xfinity that I'm connecting to. Now, that would be a cable connection, or it could be fiber optic. And I connect to a modem. We'll call it a cable modem at my house, or some form of modem that gives me access to the ISP. Now, I pay for a certain level or quality of service. And that level or quality of service, excuse me, I pay for a certain rate of throughput, data throughput. And it all breaks down to the amount of bandwidth I have. Now, when I try to explain bandwidth, the best thing I can compare bandwidth to is the amount of traffic that can flow down I-95 at any given point in time. Now, when we look at I-95, for example, if I look up, let's say, Stewart area, I may only have 4 lanes of traffic, 2 going north, 2 going south. But when I get down to the West Palm Beach area, I may have 8 or 10 lanes of traffic at a given point in time. So the bandwidth or the throughput on that segment is vastly higher than it is on the other. With that said, I've got a rule that I go by, and this rule is the system is only as fast as its slowest component. So with that said, if I pay my internet service provider for the lowest quality service they provide, I cannot expect to get any faster than that within my network when I'm connecting to the outside world. Now, that doesn't mean that my LAN that I have here, if these are all very fast devices, that they communicate at that same slower rate within the local area network. Now, if we're just talking about the local area network, in here, I connect as fast as the slowest component that I have to travel through. So if my router is very slow and I have to get out, I can only send messages as fast as that router. If the router is really fast and everything in my local area network's fast and my modem is slow, then that's as fast as I can communicate to the outside world. Keep that in mind when you are looking to acquire or purchase new hardware or new devices for your network or for your use. Things will change over time. Take consideration Moore's law, that the capacity of computing is going to double. And to me, it's about every 18 months to 2 years, but we see it on a regular basis. The capacity of computing doubling, doubling, doubling. So with that said, what's normal today will be antiquated 3 years from now, 5 years from now. All right. I need to think about throughput and storage when I'm talking about my network devices. Primarily throughput when we're talking about networked devices, but I'm always thinking about storage. So if I expand this chart will show us the different types of wireless connections. So these are cellular and satellite, and wired connections. Now beyond that, we do have other wireless connections, and they started out with 802.11a. Now 802.11 is the wireless protocol. It's governed by IEEE, and over time they have replaced what was with what is. They come up with new versions. And it goes back to what I said about Moore's law. The capacity will double at regular intervals. So what was normal at 54 megabits per second at one point in time for wireless communication, the current I can get up to 7 gigabits per second of transfer. Okay. 802.11ac, that's what we currently would see if we go out to buy it. AD is in the pipeline, and it's not far off. These protocols, by protocol, that means a way to package the data and send it across the pipeline, if you will, the network. These protocols are the rules that everything has to go by on the packaging. Think about it along the lines of you using different ways to send a package. If you send a package via FedEx, is that the same as sending a package via the US mail system? Does it matter how big the package is? Do you have to address it in a special way? Those things all lead towards you being able to send these things at a faster rate. You need to be familiar with the transfer rates associated with the different technologies of communication. Okay? So take your time and go through this. We've got flashcards available that you can go find online that will help you remember these. All right. It's a big deal remembering these numbers. Okay. All right. The difference between cable internet and DSL. Now, I can get DSL from AT&T. It's my phone company. And I can get cable internet from Comcast Xfinity, my TV company. The media that they use, the cabling that they use, is not the same. All right. It's all evolving, but in recent years, let's go back just a few years, cable connection was a coaxial cable. I can get fiber optic today, but for the sake of the discussion, coaxial cable is compared to other types of medias, the copper wire in the middle of it is substantial. It's fairly rigid in cabling because of all the insulation and shielding. And that type of cable, and we discussed the different cables and such in the CTS 1150 course, is how the data is delivered or transferred to your modem. Then from the modem, it's traditionally shielded twisted pair, where you have 4 pairs, 8 wires in a form of shielding and twisting to convey the data. Now, if we go to DSL, DSL uses a phone line. The phone line is shielded twisted pair, but traditionally it's 4 wires, 2 pairs. Now, they've been able to get a decent throughput on DSL, and it's gotten better over time. Whether you have DSL or cable, you're still going to have a modem. So on the cable, it's a cable modem. DSL, it's a DSL modem. They allow your home network, your LAN, to communicate with the WAN, the ISP. With cable internet, their signal is fairly consistent across the network because of the network infrastructure, how it's set up. With DSL, the farther you are away from the communication node, the lower your signal or quality of service. You'll have slower throughput. That's been a huge drawback over time when it comes to DSL. And we see Verizon and we see AT&T and the like, instead of having that DSL, they are installing fiber lines, fiber optic, which totally changes the game for where they were compared to where they are now. So we've got different things, images here relative to modems, connection to the outside world, and such. We've also got satellite connection, where we can communicate through a satellite to have our internet there. Often it involves a dial-up, a combination of dial-up and the satellite signal, and sometimes it is just satellite. You don't have to have the dial-up. Cellular deals with cellular towers. They're not as ugly as they used to be with the 5Gs, but we're seeing more and more of them to get higher quality signal within metropolitan areas. All right. So if you want to connect your computer to a local area network, now let's use that example that we saw earlier. You have a service from your ISP. Let's just assume that it's Xfinity. And your ISP is going to provide you a modem so that you can access data from their network. That modem has in it a network card, or we'll say NIC, network interface card. And that NIC has associated with it 2 pieces of data. One is the physical address. Previously, it was called a MAC address, media access control. Over time, that MAC address, the term MAC, has been associated with Apple devices. So rather than calling them MAC addresses, the common term today is a physical address. Any network interface card, or NIC, or network device has on it a physical address, and I'll show you an example of it here shortly. but that network device has this physical address, and we will also obtain an IP address. Now, an IP address is much like your phone number. Our IP addresses we receive from a router. Now, in that example that we had back here, it's right here. Here's the modem, and then there's a router here. So I'm going to have a router connected to my modem. The modem has an IP address from the ISP. I can take that IP address from the modem and clone it and say, all right, router, if anybody's looking for you, you're going to use the same IP address as the modem, and it's almost like you two are tied at the hip, one and the same. That router will then say to the devices on the other side, the devices in the LAN or local area network, if you want to join this network, get with me and I can send you an IP address. It's only good for a certain period of time because I only have so many, but I'll automatically renew it as long as you stay active. Usually. So, pop on up. Where was I? It was here. So on our network, come back there. On our network, the IP address is coming from our router. So our router acts as a DHCP device. It's Dynamic Host Configuration Protocol. Now, DHCP is, in essence, them handing out IP addresses. Now, much like if you're being given a phone number in the Palm Beach County area, you could get a 407, you could get a 561. I think if you're further up north, you could get another prefix on there. That lets that provider know that you are part of a smaller local logical group. We'll call them in networking subnets. So we'll have a subnet, which is a small group of IP addresses. If you're not part of that subnet, then you would have to go through to the other subnet to be able to communicate with them, because one subnet, you may have an IP address that's the same as somebody else's IP address. Kind of like we used to have a phone number here in West Palm, 832-3801. It was area code 407. And in the area code of 407, you can only have one 832-3801. But if you were in 305, down in Miami, they can have an 832-3801. With that thought in mind, the different subnets or area codes in a way, this one local area network, it's its own subnet, could have their IP address 192.168.0.0.1 or .1, and then another subnet can have 192.168.1, and the difference would be the subnets. That's a discussion altogether different, and I don't want to run down that rabbit hole right now. But to be on this network, you have to have an IP address and you have to have a physical address. Those two things are required. All right, from there, I talked about the difference between the two shielded twisted pairs. Here's the shielded twisted pair for an RJ45, which is a common network connection, and here's a common phone connection, RJ11, that has 2 pairs, 4 pairs, 2 pairs. They're color coded, and the order that they're connected within these connections matters. All right. Now, does the operating system you're dealing with have any impact on how you connect to the network? Absolutely. Where you go to set up your connection matters. So your device will have, let's say we're using Windows. You can come down to Start menu. Let me see. I'll go ahead and enter Control Panel. Here it comes up. Here's my control panel. And I can look at system and security settings, user accounts. But here's my network and internet. I can go in here. Internet options, infrared, network and sharing center. Let's go look at our network and sharing center. What do we have? Well, I've got my active networks. I'm on a domain, and I have a network adapter called my Ethernet 4, and it's a hardwired connection. If I click on that, and I'm in Windows 10, it'll tell me which type of connection I have. My IP address is at IP version 4, IP version 6. Is it enabled? How long has my connection been active? And how much throughput do I have associated with that device? How fast can I talk? I've got good numbers. So this tells me how many packets have been sent and received since I was active on the net. I can go look at the details. It'll tell me my physical address, and we see that there. It'll tell me my IP address and my subnet mask. It'll tell me the gateway. That's how I get to the outside world. And where I got my IP address from, my DHCP server. My DNS servers resolve domain names to IP addresses. So if I go into a browser and I type in google.com, if I don't have it in my local contact list, it's my analogy, if I don't have that information already locally, it'll send out a request to this DNS server and say, hey, what's google.com's IP address? They will then send back the information for me. And it's no different than if you didn't have somebody's phone number, you'll just reach out and say, hey, what's Jimmy's phone number? Boom, here's the number you're looking for. Or in the past, it would be calling information to get a phone number. All right. So we've got different types of connections depending on the network. We've got different ways to access and control the network devices. Usually going to network and sharing, and I could see what's what. Here's an example. And in this example, it's a Wi-Fi connection. Mine was a wired. I can have multiple network adapters, they say network connections, on my device. I've got a Surface. My Surface has Wi-Fi, and it has a wired connection through my workstation. So I can have multiple connections. Now, depending on if you have Win 10, Win 8, these interfaces are slightly different, but it has not changed in a long time. We can click on any one of them and disable them, enable them, connect or disconnect from the network. There's a number of things we can do. We can go look at properties and see what the IP address is. If I want to, I can manually set the IP address rather than leasing one from the DHCP server. Now, here's an example of VPN. We'll talk about VPN later. I think it's about chapter 9. What VPN allows me to do is to connect over a networked connection through a virtual tunnel, if you will. Think about it like when you go to the bank, and some banks still have those drive-throughs with a tube where you can send your money back and forth to the drive-through teller. Can anybody access what you put in that tube? No, because it's a sealed communication back and forth. Well, we create what's called a VPN through a virtual tube or tunnel, if you will. And that allows us to connect with our device at home across a network through the internet, all across the WAN, to our, let's say, for example, our office. Now, I could be at home talking to the college. I want this communication of confidential data to be encrypted and private. I don't want anybody to have access to it. So I use a VPN to connect to the system. That allows that level of security that I require. Like I said, we'll talk about that later. Okay. All right. So a dial-up connection is not something you see much anymore. That's the older lines, and you would need a specific modem for that dial-up connection. You'd have to set the phone number, your username and password associated with your account, and the type of connection would be a dial-up. With that, your modem that is actually built into your computer, it would have to be a dial-up modem, or you could have an external dial-up modem. You would connect to it, and it would then connect to a phone line, a hardwired phone line, and get you to the outside world, get you to the network across that phone system. That would be your internet service provider. It's a very slow connection. Okay. Years ago, that dial-up connection was quite loud when it was making the connection. All right. I talked before there briefly about I can go in and manually set my IP address statically. Now, there's a potential problem that comes into play. If I get my IP address from a DHCP server, then I know that I am not getting something that exists elsewhere on the network. It's a unique IP address. So there aren't going to be conflicts with other devices. If I go and statically or manually set the IP address for the device, and there is another device on the network that already has that IP address, my system will see it and say, nope, we can't work on this network because there's already a device on this network that has that IP address. So I will not be able to communicate if I do not have a unique IP address on that subnet. Okay. I talked about DNS servers and the gateway briefly before and what DHCP was. We've got two types of IP addresses. So there's IPv4 and IPv6. IPv6 has been around for quite a while, but we haven't been pressed to have to switch to the newest one. So we still lean on that IPv4 until such time as we're forced to change it. So here's what we were looking at before. Here's an example of the network connection. We go look at the properties, and then we can go into IPv4 and look at the properties of that. And here, get my IP address automatically from a DHCP server, or let's manually go in and put in what it is. So I would need the IP address, the subnet mask, and the default gateway that I'm going to connect to get to the outside world. I can get DNS server information automatically, or I can manually set those to wherever I'm going. or who I'm going to go to for that information should I not have it. Okay. Default to DHCP. That way you know you're not going to have a problem. In the labs, I set those machines up and we manually set the IP addresses to configure our own network. So that's one of the things you get used to doing, is knowing how to change that IP address. So network adapters. I can have a wireless network adapter, or I can have a hardwired network adapter. We call them network interface cards, even though they're not cards anymore. Here's an example of a wireless network adapter. That's not a card, it's a USB plug-in. It's an adapter. It's a legacy term. Okay, so we just preferred to call them a wireless adapter, but the legacy is a network interface card because they had been cards plugged into expansion slots on the motherboard. So our network adapter, or our NICs, they have drivers associated with them so that the operating system can communicate with those devices. We talked before about the different Ethernet speeds associated with the protocols that are being used. Not just the protocols that are being used, but the device itself may have limitations in how it's set up. And then we've got values that we can go in and set to make sure that it is working the way that it's supposed to be working, that it matches the rest of the configuration. I'd already talked about the MAC address and the physical address, how they're related. No two devices will have the same MAC address, or physical address, I should say. I try to lean towards that today. Can your computer have more than one physical address? Absolutely, because you can have more than one NIC, or network adapter. I can have a wired network adapter like you see here. It's an expansion card. I can have an integrated network adapter built into my motherboard. I can have a wireless adapter built into the motherboard, and I can have a USB wireless adapter plugged into a USB port. There's 4 different network adapters, all potentially connected to the same system. Each one would have their own unique physical address. Now, you'll look at and see on the back, on a hardwired connection, they'll have lights associated with them to let you know if the system is awake and working. We can go into the BIOS or UEFI setup and change the settings for that wake on LAN light. Change that if we want. It's not something that's regularly done. Now, we've got a device called a router that I've talked about already to a degree. And that device will allow us to have our own little LAN or SOHO by using the IP address of our modem as our doorway or gateway into our LAN, and then it will lease out IP addresses on our own little private subnet. Now, I can have a number of hardwired connections as well as wireless connections on my router. Okay. Here's an example of what we had talked about before. We've got our ISP to the outside world, the modem. This is all part of the ISP network. The ISP's IP address, I took it from here, I cloned it over here on the outside of my router. Now everything from this side in happens to be my LAN, my local area network. Okay? Now, I may use a switch, a router. They differ in slight forms. Switches have far more ports, and they don't do the IP addressing. They're not acting as a DHCP server. They're just sending traffic. Think about it, it's kind of like a train station where the trains come in and they change from track to track. That's a switch. A router will actually dictate who gets to go where and has access. All right. I can put locks on some switches, but that's a whole different course and a far deeper conversation. So if I have a wireless network, I'm connecting with my wireless access card, or my NIC, to a wireless access point. Here's an example of what a wireless access point will look like. It will have a hardwired connection to it. Usually it'll be a shielded twisted pair with RJ45 connection. And I also sometimes will have what we call a firewall in between our router and the modem. And that firewall is like having a security guard outside your home, checking everybody that comes and goes from your home to make sure that nobody leaves with anything they're not allowed to leave with, and nobody that's uninvited shows up. Best analogy for a firewall. Sometimes we'll have a firewall that's integrated into our router. That's a great thing. We've got to manage it and have it set up accordingly. If I want to set up and configure a router on my local network, I need to first know the username and password associated with that device. I'll access it through a web interface. Once I've logged into it, I want to change from the default admin password to a custom admin password. Make sure that you've got it written somewhere where nobody else can access it other than you. That way nobody else can get into your router with a default password. All too often people do that for whatever reason. They leave their password as what it was default and don't change it. It's a commonly known password. So if somebody sees your access point and sees that it has the default access point name, odds are that password is still the default password and they can access your network and do whatever they want to with it. So make sure you change that router password and change the router firmware password once you get into it. All right. Now, inside the router, your router, as I said, acts as a DHCP server and gives out IP addresses. We will give our router an IP address. Like I said before, we'll have the outside one will be the same as the modem. The inside one will be our system or our network IP address for that, our local area network, IP address for that device. And then the subnet mask associated with that local area network. Okay. We can see at any given point in time all of the devices that are connected to our access point, the IP address they've been assigned, and their physical address, or here it's called a MAC address. Keep in mind these are synonymous. The devices also have a name. So if your TV's connected to it, your printers are connected to it, the lights on my fish tank are connected to it. Each one of those things will be able to recognize by their physical address and the name of the device. If something's on here that you do not recognize, you can find out who it is and you can block them, block that device. If you block it by its MAC address, they cannot come back in because that's not something that can change. If we tried to block them by their device name, they can change that. And as long as the MAC address was not filtered or being blocked, they can still get back in if they had the security information that would be needed. Okay. So here they talk about the filtering by MAC address. One of the things that we hear a lot about over time is cellular systems or internet service providers throttling or limiting the amount of bandwidth for certain users. Now, why would you want to limit somebody's access to the network? Well, it would be like saying, I don't want these wide loads of construction equipment going down I-95 in the middle of rush hour. Why? Because it will slow down traffic and it'll create a traffic jam. We don't want traffic jams, so we'll do what we can to try to control traffic on a network. We can do that by managing the ports. Now, ports are virtual. They're not physical ports on the computer. Excuse me. We've got virtual ports, port 80 or port 8080 as well, are web server ports. Email service, port 25, we've got another one as well. And when the packet shows up across the network, it comes to that specific port and says, here's data for this type of communication, this specific protocol. Each port has its own protocol associated with it. And it has to do with the packaging of the packets that as they come across. All right. Once we get into the system, we've got what's called port forwarding. The router can do some filtering and then they forward it to specific servers based on specific ports. Okay. So we can configure our router to filter specific ports coming in and coming out. I may not want traffic coming across a certain port. I can lock it down. And they've got a cute little graphic here. Like I said, this is not the firewall side of it. It's an additional level of security. It's much like having a security guard saying, let me check your ID. Now, I can have a DMZ, which that DMZ is an area of the network that is not protected by a firewall, or it has limited protection. And I need to be cautious about what's taking place, who has access to these DMZs. All right. So wireless or Wi-Fi means wireless fidelity. I talked briefly before about the different protocols, where it comes from, IEEE. We're on 802.11ac, 802.11ad is not far off. We talked about the different protocols associated with each, whether they're using 5 gigahertz or 2.4 gigahertz radio frequency communication can dictate our range, how far it can communicate. We also have not just the range of these devices, but we also have the throughput that we have to take into consideration. Okay. Here's an example of a wireless access card. And we'll have a security key associated with that wireless communication. And the key allows us access to the encrypted communication. If you don't have the access key, you cannot get onto that wireless network and communicate across it. We've got different types of wireless encryption. Each one has a higher level than the lower level. So WEP, it's a key that is static. This is quite an antiquated system, and it did not take them long to be able to hack a WEP security code. As we come up in levels, the level of encryption, the length of the key becomes more complex, and it becomes more difficult to hack or crack that key. But we also need to keep in mind that with Moore's law, the capacity of computing keeps doubling, processing power keeps getting more powerful. It makes computers more likely or more able to hack these keys. So we're going to, over time, keep coming up with new security protocols to stay one step ahead because of the processing capability or capacity. Now, the SSID is the service set identifier. That's technically the name of your wireless access point. Not only are you going to change the name of it, you're going to change the password to get into it. So I don't want anybody to know the name. I can have it to where you have to know the name to talk to it. I don't want to broadcast and let everybody know what my name is. So if you don't know what it is, you can't communicate with it. It's like an out of sight, out of mind kind of thing. All right. So troubleshooting network connections. First off, we need to know how these things communicate to be able to know how to resolve any issues. All right. And one of the things that we can do is we'll use a command prompt. We can ping other devices and see, do we have an actual connection? And we'll find out how long it takes to get a response. So they are pinging 69.32.208.75. They're sending 32 bytes of data. How long did it take to get a response? How many did we get back? We got 32 back. It took 47 milliseconds. And the time to live on it was 242. So I know how long it takes to get these packets back. They're not necessarily all going to be the same. We send 4 packets out. Hopefully we get all 4 packets back. There may be an instance where we ping something and we get no response. It's a way for us to test the communication between 2 devices. I need to know their IP address, or I can ping them by their physical name or their device name. Not the physical address, the device name. As long as that can be resolved, I can ping them. We've got ipconfig/all will tell us, I ran that earlier, that'll tell us the different network configurations for the different network adapters within the given system. I can release the IP address. I can renew it, meaning go get another one from the DHCP server. I can manually change it. I can change my DNS server. There's a number of different things I can do using a command prompt to find out what my network status is or modify my network configuration. I can use NSLOOKUP to check for namespace or name server lookup, and that resolves the name to the IP address. I've also got that DNS that'll resolve the IP address to the domain name. Right. It's commands that we can run on our command prompt. There's also Traceroute, we'll call it Traceroute, and that allows us to see the path that packets have gone down hop by hop through a network. Now, they ran one here and we see it's gone through Cincinnati. We don't know where it came from or where it's going to, but we send information across the network to a destination and we see each of the hops, how long it took between hops, the IP address and physical address and the name of the devices that we're going across. And that allows us to see what's the path that we're going through to get where we're going. You know, I used that analogy of traffic in, let's say, I-95. If I was sending somebody to get me something from a store. And it traditionally takes 20 minutes, but it took them 3 hours. My question is going to be, what was the path you took to get there? Now, if they said, why? Does it matter? Absolutely it matters. I don't need you going through LaBelle to get to Delray Beach. There's no reason to do that. So, well, I got there. Wait a minute. These kind of things we need to look at to find out, why is the traffic getting slowed down? What's taking place? I run my command prompt by going down to my system, doing a search for CMD. Excuse me. And that'll open up a command prompt. Excuse me. I can go through and run a number of different commands on that command prompt. Get familiar with them. Here's different commands that you can run here and examples of them. Now, here's a summary, but one of the things I want to see beyond something they really didn't hit on so much, I can do Control-Alt-Delete and run Task Manager. Task Manager has network performance in it. I can go to performance and look at my Wi-Fi or my Ethernet, which is hardwired, connection across the network, and see send and receive speeds. I see my IP address, the domain that's hardwired, that's the connection I'm dealing with, is Ethernet 4, that adapter. And I know what the maximum throughput they're expecting it to be. It's a gig. So I can see what's taking place here. All right. There's different places I can look to try to troubleshoot my network. Okay. So we've covered a lot of information in this. Make sure you spend time on those labs. Go knock out the ones that have credit associated with them first. See where you stand. And then if you need reinforcement, go to the lab manual ones to get that reinforcement. Okay. I'll see you in the next module.